H-3. The H-3 rocket is a Japanese medium-lift launch vehicle, MLV, developed by the Japan Aerospace Exploration Agency, JAXA, and Mitsubishi Heavy Industries, Limited, MHI. It is the successor to the H-IIA and H-IIB rockets, designed to reduce launch costs through the use of the lower-cost LE-9 main engine. The H-3 features a modular design with 2 or 3 first-stage engines and 0, 2, or 4 solid rocket boosters, allowing it to accommodate a variety of payload sizes. Development began in 2013, and the first flight took place in March 2023. The launch ended in failure when the second-stage engine did not ignite. The first successful test flight occurred in February 2024. MHI oversaw development and leads final assembly of the H-3 rocket and its liquid fuel engines. IHI Corporation produces the liquid fuel engine turbopumps and solid fuel boosters. Kawasaki Heavy Industries Limited, KJ, builds the S-type and L-type payload fairings, and Toray Industries Incorporated supplies the carbon fiber and synthetic resin used in the booster motor cases and fairings. Beyond Gravity manufactures the W-type fairing based on its standard 5.4 meter wide, 18 feet, design. The Japanese government authorized development of the H-3 on May 17, 2013. The vehicle is being jointly developed by JAXA and MHI to support a wide range of commercial satellite launches. Compared with the H-IIA, the H-3 rocket was designed with simpler, lower-cost engines to reduce manufacturing time, technical risk, and overall expense. JAXA and MHI were responsible for preliminary design work, ground facility readiness, new technology development, and manufacturing. Cost reduction was the primary design goal, with launch prices projected at about $37 million. As of 2015, the first H-3 rocket launch was planned for Japanese fiscal year, JFY, 2020 in the H-330 configuration, which lacks solid rocket boosters, followed by a booster-equipped version in JFY 21. The newly developed LE-9 engine was the key to cost reduction, improved safety, and higher thrust. The engine employs an expander bleed cycle, a combustion method previously used on the upper stage LE-5 engine, and never before used on a first stage. While such cycles typically cannot produce high thrust, the LE-9 was designed to reach 1,471 kilonewtons, 331,000 pounds force, making its development one of the most significant challenges of the program. Ground tests of the LE-9 engine began in April 2017, and the first solid rocket booster tests were conducted in August 2018. On January 21, 2022, the first H-3 launch was postponed to JFY 22 or later due to technical issues with the LE-9 engine. The first launch attempt on February 17, 2023 was aborted just before ignition of the SRB-3 boosters, although the main engines had successfully ignited. So, the second launch attempt occurred on March 7, 2023 at 1 hour 37 minutes and 55 seconds Coordinated Universal Time, UTC. Approximately 5 minutes and 27 seconds after launch, the second stage engine failed to ignite. With the rocket unable to reach the required velocity, JAXA issued a self-destruct command 14 minutes and 50 seconds after launch, destroying the Advanced Land Observing Satellite 3, ALOS 3, also called Daiichi 3, satellite along with the launch vehicle. On February 17, 2024, JAXA successfully launched the second test rocket, configured as an H-322S. During this flight, the second stage reached the intended orbit, marking the first fully successful H-3 launch. The H-3 is a two-stage launch vehicle. The first stage uses 2 or 3 LE-9 engines fueled by 225 tons, 496,000 pounds, liquid oxygen and liquid hydrogen, hydrolox, propellants. The first stage can be fitted with 0, 2, or 4 strap-on SRB-3 solid rocket boosters, SRBs, derived from the SRB-A and fueled with polybutadiene. The second stage is powered by an upgraded LE-5B3 engine and carries 23 tons, 51,000 pounds, of hydrolox propellant. H-3 configurations are identified by a 2-digit number and a letter. The first digit indicates the number of LE-9 engines on the core stage, 2 or 3, while the second digit indicates the number of SRB-3 solid rocket boosters, 0, 2, or 4. The final letter specifies the payload fairing, short, S, long, L, or wide, W. For example, the H-324L has 2 LE-9 engines, for SRBs, and a long fairing, while the H-330S has 3 engines, no SRBs, and a short fairing. As of November 2018, 3 configurations were planned, H-330, H-322, and H-324. The H-332, a proposed variant with 3 engines and 2 SRBs, was cancelled in late 2018 after tests showed that the H-322 offered better-than-expected performance, reducing the need for the more powerful version. JAXA cited commercial precedent, noting that SpaceX's Falcon 9 Block 5 frequently launched satellites into a low geostationary transfer orbit, leaving the satellites to raise themselves to a geostationary orbit. Since commercial clients appeared willing to accept this trade-off, JAXA concluded that customers would prefer the less expensive H-322 even if it required additional onboard satellite propellant. As of July 2015, the minimum H-330 rocket configuration is to carry a payload of up to 4,000 kilograms, 8,800 pounds, into Sun-synchronous orbit, SSO, for about 5 billion yen, equivalent to 5.1 billion yen or $46.76 million in 2019. And the maximum configuration is to carry more than 6,500 kilograms, 14,300 pounds, into geostationary transfer orbit, GTO. The most powerful H-324 variant will deliver more than 6,000 kilograms, 13,000 pounds, of payload to lunar transfer orbit, TLI, and 8,800 kilograms, 19,400 pounds, of payload to geostationary transfer orbit, GTO, increment V equals 1,830 meters per second. As of October 2019, MHI was also studying 2 concepts for potential use in NASA's Lunar Gateway program, an extended second stage, and a heavy-lift version with 3 liquid-fueled core stages strapped together, similar to the Delta IV Heavy and Falcon Heavy. The proposed H-3 Heavy would have a payload capacity of 28,300 kilograms, 62,400 pounds, to low Earth orbit. H-3 will have a dual launch capability, but MHI is focused more on dedicated launches, in order to prioritize schedule assurance for customers. As of 2018, MHI is aiming to price the H-3 launch service on par with SpaceX's Falcon 9.